Hi everyone, I am Abhijit Bhattacharya and I am currently a final year undergrad student at Bharati Vidyapeeth's College of Engineering, New Delhi. Today I will present the Clearview dataset, the first ever public dataset made for reconstruction of missing data in remotely sensed images. This work is done with my co-author Tanmay Baveja, also a final year undergrad student at Bharati Vidyapeeth College of Engineering. Remotely sensed data is very useful to us and each country. It is one of the most important ways of exploring and monitoring human and biological activities on Earth. It is also used in obtaining the geometric attributes and physical properties of Earth's and other planets' surface. These are amongst the best and most efficient approaches to understand and investigate our planet. These satellite images serve various purposes varying from a country's national security to exploring the planets and stars millions of light years away from us. Considering these satellite images of Earth's surface, only these images have numerous and applications to the human mankind. It can also be used to monitor any type of disaster, predict the scale of the disaster, predict and identify the region of high impact due to the disaster. These satellite images can also be used to recover the people hit by the disaster. It is also used by many countries' military armed forces to monitor their borders and keep an eye for any terrorist or enemy attacks and anticipate them and be prepared for it. Numerous weather stations also use this data to predict the weather of coming days or weeks. Many police and intelligence forces use these satellite images to detect any type of anomaly in the area or any suspicious activity happening in the area. It is also used to track terrorist hideout and their bases. Many anti-narcotic agencies can also use these images to track the cartel of drugs and smuggling of illegal things across the border. It is also used to predict the yield of the crops and keep an eye on big farmlands. These remotely sensed data can be accessed by public freely from many agencies and organizations online. The main organizations are USGS Earth Explorer. This stands for United States Geological Survey. This is a very well made website for accessing the satellite images. We can find a record of 40 years worth of data in this website. It contains satellite images from many sensors and many different satellites. For examples, the NASA's Landsat mission satellite, Terra Aqua Modis satellites, ESTER satellites, and also some ISRO satellites, for example, RioSat 1 and 2, Sentinel 1 and 2, etc. Land Viewer. Land Viewer offers a miscellaneous free global satellite images. We can find up-to-date satellite images from Landsat 7 to 8, Sentinel 1 and 2, and etc. Next comes the Copnius Open Access Hub. It offers the latest free satellite images from all active Sentinel sensors, radar imagery from Sentinel-1, optical multispectral to Sentinel-2 imagery. Sentinel-3 and Sentinel-5P sensors are also available in this website. Next comes the Sentinel Hub. It holds a dozen of medium and low resolution satellite imagery sets, including complete archive of the Sentinel missions. Landsat 5 to 7 and 8 of MODIS, NVSat Meris, PROGBA 5 and Gibbs sensors can also be seen here. Next is the NASA Earth Data Search. It has a huge amount of satellite data from Aqua and Terra, NVSat, GOES, NOAA satellites. Other sensors and satellite also includes Meteostat, Xiaomi NPP, Nimbus, Calypso, Landsat, and other satellites. Here we can see the satellite images of the atmosphere, environment, ocean, seas, land cover, vegetation, ice cover, and many other topography. Next comes a Next comes a successful project known as Remote Pixel. Remote Pixel features only three satellite imagery dataset. For example, Landsat A, Sentinel-2, and CVERS-4. Next comes INPE Image Catalog. INPE Image Catalog is a go-to source for free satellite imagery maps of South and Central America and Africa. It features satellite images from Brazil and China's joint mission CBERS-4 alongside US, UK, and India's Earth Observatory missions Aquaterra Landsat 8, Riosat, Xiaomi NPP, and many other sensors can be found here. However, unfortunately, these satellite images suffer a data loss in various types of noises caused by many factors such as extreme weathers and harsh condition in space and various other types of waves and rays with various frequencies. Some of the most common noises experienced by these remotely sensed data are cloud obstruction, the view of the satellite and Earth surface. This is a very common type of noise in the images. These noises are very common in satellite images in many countries. For example, Canada, where 50% to 80% of the Earth's surface is covered by clouds in the mid mornings. Since cloud cover is frequently inevitable in the observation progress, passive remote sensing data lacks much more information. Next is the salt and pepper noise. This noise can be used by sh- this noise is caused by sharp and sudden disturbances in signal images. It is present itself as a sparsely occurring black and white pixels. It appears as if someone has spilled the mixture of salt and black pepper in the image. Next is the ETM plus SLC noise. This type of noise occurs due to technical glitch or some failure in the electronic circuit. It appears like some lines have become dead and have turned into black, giving it a design of thick black lines on the satellite images. Next is the deadline noise. This type of noise is very much similar to the ETM and SLC noise. This type of noise is recognized by thin black lines all over the satellite images. Next is the Gaussian noise. This type of noise is also very common in satellite images. It makes the whole image blurred and deteriorates the resolution of the image. Next is the speckle noise. This type of noise appears as scatters present over an image on a scale of incident radar wavelength. All these noises are not random and are caused by various factors. The factors are for the cloud obstruction. This type of noise is caused by the clouds in the sky which block the view of the satellite of the Earth's surface. Next is the salt and pepper noise. It is also known as impulse noise. Salt and pepper noise refers to the wide variety of processes that result in same basic image degradation. Only a few pixels are noisy in this, but they are very noisy. This noise is caused by sharp and sudden disturbances in the image signal. It can also occur due to error in transmission over noisy digital links of image or an error in the conversion of certain analog value to digital value. It presents itself as a sparsely occurring black and white pixels. Next is the ETM plus SLC noise. This stands for Enhanced Thematic Mapper plus the scan line corrector noise. This mainly occurs due to some faulty electronic components or poor performance of satellite sensors. This also occurs due to crosstalk between the sensors of the satellite. This noise is a symptom of serious and sudden event on the satellite or the instrument. As a system or on board the satellite fails, the electronic anomalies can create sudden and brief bursts of noise that exhibits coherent frequency. This noise is observed in most bands, but it was highest in band 1 and 8, where detected ringing events were previously observed. Next is the deadline noise. This type of noise is very common in aqua Morris sensors and highly occur in band 6. This also has a common cause of ETM plus SLC noise, and additionally can be caused by vibration in calibration across the sensors array in multi-sensory instruments and drop lines due to scanning. Next is the Gaussian noise. Principal source of Gaussian noise arise due to acquisition. This happen in satellite images due to extreme low and high temperatures of the electronic circuits and sensors in space. Noises injected by other sensors in the electronic board also contribute to Gaussian noise. The speckle noise. This is a granular pattern, a special kind of noise that is mainly found in the satellite images. Removing this noise is one of the major challenges and least touched issues. This is mainly caused by random inferences between the coherent returns issued from so many scattered present across the Earth's surface. All these types of noises degrades the satellite images, and it loses a large amount of information about the Earth's surface due to high spatial resolution, where one pixel corresponds to a certain meter square land. So the loss of even a single pixel has to be avoided in each case. These noises also act like holes and discontinuities in the images, and these noises differ from other general images, which makes the machine learning model very sensitive towards these type of noises and reduces their ability. Also, these machine learning models accuracy also decreases significantly due to these noisy images in the training set. These noisy images also affect the other algorithm applied to it and tamper their performance and manipulates the image's results. Therefore, restoring the lost information and satellite images become an important task before applying any other algorithm. So we present a Clearview dataset, a novel dataset containing these noisy satellite images made specially for reconstruction of these missing data in the remotely sensed images. This dataset is free and can be accessed by anyone in the given link. This dataset contains only a normal RGB images as an average human would perceive it from above the Earth's surface. Also, the mask of the images is also provided alongside the noisy and their label. This dataset has 3 out of 6 most common noises in the satellite images, and all the noisy images in the data have a spatial resolution of 0.3 to 1.5 meter, which means a single pixel in the satellite image would be equivalent to 0.3 to 1.5 multiplied by 0.3 to 1.5 meter land on the Earth's surface respectively. These are the types of noises present in this dataset: cloud obstruction, land ETM plus SLC noise, and salt and pepper noise. This dataset has 63,240 images, out of which 21,080 are the noisy images containing 3 types of noises with the corresponding masks and labels arranged in different folders. This dataset is mainly made for supervised learning, but it is not restricted to it. The table in this slide shows the number of images per class and the resolution of the images. All the all these satellite images are collected from a total of 19 places all around the world. The algorithm used to make this dataset can be seen in this image for cloud detection. We looped over all the images in the noisy folder and defined a NumPy window of 64 cross 64 and traversed this window all over the image and summed the pixel value in the windows, and if the sum of the window was over a threshold value, it would be marked as it would mark the presence of a white region and it would be classified as a cloudy image, and after that it would be moved to a different folder. If the value was below the threshold, it was skipped. We also used the same method to detect the ETM plus SLC noise. We just had to reverse the if condition to detect a black region in the satellite image. Almost all the noisy images were detected using this algorithm out of the two classes of the noisy image. The rest of the images were segregated by human supervision. The remaining images were of the third class of salt and pepper noise. This Clearview dataset is very useful to machine learning community in many ways. This dataset focuses on very current problem of processing incomplete data from remote sensing images. This targets a really focused and troubling problem statement to researchers and aims to provide an infrastructure to solve missing data problem in remotely sensed images. This dataset can also help the UAVs equipped with cameras in numerous ways and make their computer vision algorithm less sensitive towards this noise. It will also help and motivate the researchers to explore the field of satellite images in great detail. Further, it will also encourage the spirit of improvement in visual recognition method for remotely sensed data. So for the future work, we are planning and interested in introducing other type of noises in this dataset in future. We would also like to add we would also like to make this dataset target more tasks such as semantic segmentation from satellite and make this dataset even larger, containing different components targeting different problem statements. We would also like to introduce other type of images, for example X-rays, infrared, and other types of images. Thank you.